Ji, Assalamu alaikum. Today we will continue with the next bone in development. We've talked about the development of the skull, all the different neurocranium and the viscerocranium, how the whole of the skull, the different parts of the skull were formed. We said that part of it was formed, the frontal portion was formed by the neural crest cells, and the posterior part was formed by the paraxial mesoderm. And then we talked about the development of the mandible and the hyoid bone, which we will talk about in detail when we talk about the pharyngeal apparatus. Today we are going to talk about the development of a vertebra. That is a general pattern that how a vertebra or the vertebral column develops. The typical parts of a vertebra, just to recollect, are the vertebral arch, that is your anterior portion, the vertebral foramen, the body, the transverse process, and the spinous process. These are the different parts. So when we talk about the development, we will have to talk about the formation of each of this part. You see this picture, that tells you the first is the arch, the body, the arch, the lamina. They are processes: superior inferior articular process, transverse process, spinous process, the spinal canal, which contains the spinal cord, and then you have the intervertebral disc. These are all what have to be developed when we say we talk about the development of a vertebra. We're talking about the development of the vertebral column as a whole, because we'll talk about how the discs are formed and then how the curvatures and what are the anomalies which are related with it. What we're going to talk about today is what are the different stages of the development of vertebral column. In that, it is intracartilaginous, but first it is going to be the formation of the mesenchymal model, and then this is going to form the cartilaginous model, and then it's going to go over to the ossification. So these are basic the stages. That is, first a mesenchymal structure is going to be formed, then there is appearance of the cartilage, it converts into cartilage, and then it converts into the ossification. Then we have to say what is the fate, because this is going to form around the axial skeleton, that is your notochord. Then we have to talk about what is the fate of the notochord. And then the coastal processes, because in different vertebrae, different features are there. So we have to talk about the fate of the coastal process. But today we'll just concentrate on the cervical vertebra. And then the anomalies. So these are the different things which we talk about when we talk about the vertebral column. What are the stages of the development of the vertebral column? Vertebra, they form from where exactly is the initial starting, or where is the foundation stone of the vertebra, is from the sclerotom. If you remember, sclerotom is a part of the mesenchyme that lies around your neural canal, and the notochord, that is in the center, where you had the formation of your paraxial mesoderm, intermediate mesoderm, and lateral plate mesoderm. This paraxial mesoderm, the dorsolateral part, is going to spread out and form the sclerotom. Is the formed from the sclerotom portions of the somites, which are derived from the paraxial mesoderm. So sclerotom is the important thing which is going to form, and these sclerotom, they take origin from your paraxial mesoderm. If you see in this picture, to recollect where we are talking about, is the center blue is your neural tube, that is number 1. 2 is the below is your notochord. Then is the somite that was on the sides, which is broken up into its components. That is, it's going to form the sclerotom, that is the dorsolateral portion, that is going to spread out and form. The upper part is going to form the dermomyotome, and the rest is going to form the sclerotum, that is the third, that is going to spread around, and it's going to spread around in two places majority, that is around the neural tube and around the notocortex sclerotum and around the body wall. So these are the three places where these sclerotum cells are going to spread out. So that is paraxial mesoderm. Part of the paraxial mesoderm becomes your sclerotum, and this sclerotum is going to form your vertebral column. This picture shows you the migration of the sclerotomes. That was the initial portion, that is the neural groove tube. Then the neural tube was formed. Then the sclerotome, it spreads over, and then it's going to spread over and go around your neural tube and the notochord. So this is the migration of the sclerotomes, which are going to ultimately become your vertebra. Now, sclerotomes, when they spread over, they're going to go in three areas in the fourth week. All this development starts in the fourth week. It's around the notochord, one, it's around the neural tube, if you see in this picture, and it's in the body wall. These are the three places where you find the sclerotome. Around the notochord cells are the sclerotomes. They are arranged loosely, cranially. They form and densely chordally. So in the next picture, if you see, they form two layers. One layer which is loosely arranged, that is the cranial, which is light pink in color, and densely it is denser, which is your densely arranged. So it arranged not all over, it's not the same, but it is loosely and densely arranged because it is going to form different components. So the packing of sclerotome is in two ways. The central ground portion is your notochord, and these are the cells which are around it, and then you have the muscles, and then you have the ectoderm, which is going to form your skin. Now we've reached the foundation, we've laid the foundation, but now what is going to occur? The first step is the formation of the membranous portion of the vertebral column. That is how that part is going to form. That is from starting from the fourth week. That week, which is going to be called as the mesenchymal stage, precartilaginous stage, or the blastemal stage, all is the same. That means the membranous model of your vertebra. What happens is the differentiation of the sclerotome segments. That is how they are modified to form the mesenchymal. That is what you form a solid structure, which is what we call as your vertebra. So each segment is differentiated into, at this stage, into a pelvic part, which is the less condensed part, and caudal part, which is the more condensed part. I showed you this picture. This. Okay, this is what is going to occur. The two portions. Then if you see in this picture, this again tells you that in the center you have the notochord, if you see the first picture, and then you have the arrangement of the sclerotome on the either sides, that is the black one, and then on the either sides you have the myotomes, those are the muscles which are going to be related with it. The yellow is the nerve, and because in the center you're going to have your vertebral canal with the spinal cord, and then you have the blood vessels, right? So this is the arrangement, that is with the densely arranged and the loosely arranged. This is how the cord is going to be arranged. There is something what is going to happen, what we call as your resegmentation. This resegmentation is going to occur opposite the center of the myotome, densely packed. Now, if you see the slightly porous part around it and the densely part around it, so they are going to move their blobs. They are going to move the densely packed move cells. That is, this one is going to, half of it is going to move upwards towards the less densely packed myotome, and half of it is going to move downwards to the lighter portion of the myotome, this block below. So when it moves upward, this dense part, this is going to form, half of it goes upwards and half that. When half of it goes upwards, that is, it's going to contribute with the vertebra above. And if it just goes downwards, it is going to contribute with the formation of the vertebra below. But in between, where you have this cut, that is the area what we call the sclerotomic fissure, and this is where you develop your intervertebral disc. If you see this last picture, and if you see in the second one, there is the fusion of this. That means these two process. This, the dense one is, half of it is going upwards and half it is going downwards, and it is fusing with the less densely packed area below. And if you see this picture in the third one, you can see that because of the splitting up of this dense material, half of it is, there is less mesenchyme there, and this is the area where you're going to develop your intervertebral disc. So you see the this first block above, loosely arranged and then densely arranged. This densely arranged block is going to split into two. Half of it is going to go and unite with the less densely part above, and half of this dense portion is going to go and unite with the less dense portion below. So this union of less dense and the thicker portion is going to form the body of the vertebra, and the portion which is split in between, that is what we call as the sclerotomic fissure, and this is ultimately going to become your intervertebral disc. The remaining dense cells fuse with the loose cells below, that is your mesenchymal. So one is going to go upwards and one half of it is going to go downwards. And where you fuse the two cells, that is the dense from above and loosely arranged from below, they are going to form your mesenchymal centrum. That is the foundation stone or the mesenchymal block of your vertebra. This is resegmentation, that is going upwards. It's not that what is at one level, the caudal and the dense and the less dense portion at that level is going to combine and together and form the vertebra. It's the fusion, that is, the segments are going to rearrange. That means the dense segment from above is going to, half of it is going to move upwards with the less dense segment of its uh, segment, and half of it is going to go downwards and combine with the less dense segment and form the centrum. So that is this process, and this lays down the formation of what we call as the mesenchymal centrum. This is what we call as resegmentation. The original segments, that is what were formed when there was forming of a caudal and a cranial thick and thin segment, that is not going to form as it is the vertebra, but there is going to be a rearrangement of these segments. And that rearrangement process is called the resegmentation. If you see this picture, very clear one, these are the different blocks. Mesenchyme from one somite. This is going to then break up into halves. If you see that from the green half, upper half of the green with the lower pink, that is the portion that is going to come and unite, and they are going to form the body of the vertebra. Because you are splitting the pink into half, so that half portion is going to form the precaudal disc, or what we call as the intervertebral foramen. So same is the case with this green. If you see that half of this is going to go upwards and half of the dense below was going to go downwards, and then the space in between is going to form your intervertebral disc. So these splitting off or meeting up of or shifting of this part, this is going to form what we call as the resegmentation and formation of the body. ठीक है. Now if this you see in this diagram, the cranial less dense part, the condensed part, and the caudal less condensed part. ठीक है, these are the two. So this condensed part has gone below to meet the less condensed part, the pink part of the part below, and then this upper one has gone to meet with the condensed portion above. So all this rearrangement is going to form the vertebral body, you see, and then the space in between is going to form the intervertebral disc. That is how the resegmentation is going to occur, and the bodies of the vertebra are going to form. Then that is the mesenchymal block is going to form. Then the development of the intervertebral disc. Densely packed cells move cranially to the middle part of each segment. From the peripheral part, that is of this mesenchyme, that is going to form your annulus fibrosus. The notochord in the center is enclosed. Notochord expands and undergoes mucoid degeneration, and the notochord in the center from the central part is the nucleus pulposus. So the cells which moved up and down peripherally, those it's going to fill up the space that is going to form the annulus fibrosus, and the nucleus pulposus, which was going in the center, is of the notochord, that is going to form the nucleus pulposus. That forms the intervertebral disc. If you see a continuity of this picture, this was the notochord and the two cells. Now this is going to go, the lower block, the dense portion of above goes to the less dense of below, and then this is going to fuse and form the body. And this half portion which is above is going to be less dense, and this is going to form your intervertebral disc by the formation of the mesenchyme on the sides, and the nucleus pulposus, the notochord, is going to form the nucleus pulposus, and this is the final product of your vertebral column. That is, the vertebrae are formed. Now another thing along with it is that is the body is formed. That there is a blood vessel coming out from it, and there is a nerve. You know that the spinal nerves are coming out. Now initially when you start formation, the model is that the arrangement of the nerve is not at the intervertebral disc, but it is in the middle of the body. If you see in the first picture, artery is at the center of the, it is initially at the place where the intervertebral disc is, that is in between the blocks. That is the first step. When this resegmentation occurs, the place changes. That is because half goes up and half goes down. And what happens is that the level of the nerve shifts onto where the formation of the intervertebral disc is, and the blood vessels become at the place of your nerve, that is in the central portion, at the central middle portion. So that is the final position. If you see in the final product, that lies is the final position of the formation of the or the arrangement of the blood vessels. So that is because of, if you see in the first picture, then in the second one, the segmentation shifts the placement of the nerves and the arteries, and then you get the final. That is how you have the exit of your intercostal nerves or the nerves coming out from the spinal cord from the respective vertebral space. So that is from the intervertebral disc. So that is how it comes out and it supplies to the muscles, right? And your nucleus pulposus, that is formed by the notochord, that is going to form the intervertebral disc, and the mesenchyme on the side is going to form the annulus fibrosus. Chordoma results into the, we've already said, as the remnant of the intervertebral disc. Then is the development of the body of the vertebra. Caudal remain part fuses with the cephalic part adjacent to it to form the mesenchymal centrum. Centrum is the body part. Notochord degenerates and disappears surrounded by the vertebral body. So that is the body is formed. Then if you see in this picture, the center is the notochord, and then you have the lighter portion, that is the part of the sclerotomic or the discs which are there. The one is the sclerotom. Then you have the third is the intervertebral disc, which is gonna, if you see when due to the rearrangement, the level of the disc has shifted upwards because half from above and half from below have fused, right? So your intervertebral disc goes a level above. Notochord becomes your nucleus pulposus, and then this becomes the body. Okay, the body of the vertebrae. Then development of your neural arch. Sclerotomic tissue migrate backwards from both sides of the centrum and surround the neural tube. Neural spine forms a meeting point of the neural arch. So sclerotomic also extends laterally from both sides of the centrum to form the processes, that is the costal, the transverse processes. So the sclerotom, that is going to go round the spinal cord, and then it is going to form the neural arch, that is it's going to extend into the spinous processes, and it also gives laterally some processes which are going to form the ventral one, which is called the costal process or the transverse, and the dorsal one is going to become the transverse processes. Then costal processes are going to be different in different vertebrae. Results from ventrolateral outgrowth of the caudal, denser half of the sclerotom. In the cervical region, the interior and the lateral boundary of the foramen transverse area. These are going to be the costal processes which form, they're going to form the interior and the posterior lateral boundaries of your foramen transverse area. If you remember, foramen transversarium is the opening in the transverse processes. So that is how you identify that in the cervical process. In the thoracic, it is going to form the ribs, this process. The lumbar region fuse with the transverse process, and upper sacral unite to form the portions of the ila. So the initial starting point is going to be the same, but it's going to be different. So you just have to remember of the cervical. Then, because of what happens because of the resegmentation is three things. The myotomes of the myotomes to bridge the intervertebral disc, that is, they are at the level where you have the intervertebral disc. If you see this picture, they are where you have the intervertebral disc, they are bridging, this red is going to bridge onto the intervertebral disc, these myotomes. One structure is that which is going to happen at the end of the resegmentation. Second is the nerves, they are going to shift from the middle of the body to the intervertebral disc level. And third, the blood vessels which were at the level of the intervertebral disc initially, they are going to shift upwards to the level of the body. So these are the three things which are going to occur when you do the resegmentation of the body. Okay. Intersegmental arteries lying between the sclerotomes now pass midway over the vertebral bodies. Spinal nerves come to lie near the intervertebral disc and leave the vertebral column through the intervertebral foramen. So this reshuffling is because of the arrangement of the resegmentation. You see this picture, This center is your vertebral column or the neural tube. Coming the nerves, then you have on the sides, then you have the notochord, and these are your sclerotomes. Initially, your nerve was coming out, it was in the middle of the body and going on to the myotome. You see, and the blood vessel is coming out from the middle. So at the level of the intervertebral disc. So you have the cranial myotome which is going to go upwards, and caudal is going to go and unite with this lower one. So if you see the direction of the arrows, it will be very clear. The You see this arrow that is going to come down the caudal sclerotome and meet the cranial, the sclerotome cranial portion from below, and it's going to unite together. So and in the middle, this is going to form the mesenchyme, which is going to become your intervertebral disc, through which the body of the vertebra, and through which the center is going to pass. If you see the next diagram, in this center is going to pass the blood vessels, and this junction where you go up and down, that is the area where you're going to form the intervertebral disc, and this nerve is located then into at the level of your intervertebral disc and the come from the intervertebral foramina. So this diagram is very clearly helpful to explain how the resegmentation occurs and where the placement of the vessels go and the nerves go. This also shows you the nerve which is coming out. Then it's between at the level of the body going to the muscle. Then resegmentation upwards, upper and below. This resegmentation makes this body is splitting it into the intervertebral disc, taking the nerve to the muscle. So this also shows you how the different vertebrae are formed and how the placement of the nerves is shifting because of the rearrangement. This is resegmentation. Initially, you had this light pink and the dark pink. This moved upwards and downwards. The nucleus pulposus is formed and the nerve goes to that level and the blood vessels come into the middle. If you see it in this picture, there is the rearrangement. This also shows you how the sclerotome is moving and changing on to the position, how the nucleus pulposus is formed, the body is formed, and then because of this resegmentation. So what we found is after all this in the mesenchymal process that we form a centrum, that is the body. We have formed posteriorly what you have this, that is the neural arch, and then you have the posterior processes. This is ultimately all what is formed in the mesenchyme, that is the structure. So you have the center, you have the posterior processes and the neural arch. That is a mesenchymal model which is formed around the notochord or the neural tube. This was the mesenchymal vertebra. Okay? So that is the vertebral foramen. These are the posterior processes. 4 is the body, and that is where you are going to have the vertebral arch, where you are going to have the spine. So that is a model of the mesenchymal vertebra which is formed. By then we are going to go on to the cartilaginous stage. How the cartilaginous model is going to form when this mesenchymal model is going to be converted at roughly 6 weeks into the cartilage. Process of chondrification. There are two centers of chondrification in each centrum pair, that is two parts where the cartilage is going to arise. They fuse together at the embryonic period, 8 period, and they form the cartilage, the centrum becomes cartilage. Centers of chondrification appear in the neural arches and fuse with each other, and chondrification spreads until a cartilaginous vertebral column is formed. If you see this picture, all these dark brown ones are in the posterior processes. In the arches, you have all the processes, that is the sites, as we say, the ossification centers. This is the chondrification center. 6 week in the mesenchymal vertebra, centers appear in the centrum and the neural arch, all fuse with each other. The spines are extensions of these neural arches, and they spread onto the vertebral column. So a chondrification occurs in the mesenchymal model. 2 in the body, 2 in the posterior processes and the arches. Then the next stage is it's going to become bone. The stages of ossification of vertebral column comprises of 2. As we've all said, everywhere it is primary ossification center and secondary ossification center. The same is the case in this. The primary ossification center is roughly at 8th week. three ossification centers are present by the end of the embryonic period. One in the centrum, when we say centrum, we are meaning the body, and one in the neural arch. Okay, if you see this one in the centrum, this brown one, and then is this neural arch, these are there. So you have primary centers, the centrum, and then you have three centers, one centrum and two neural arch centers. These three bony parts, they're joined by cartilage. 3 to 5 years where these lumbar regions half up neural fuse together cranially. They're going to, so by the end of third to sixth year, the spinal cord growth disappears, and these are joined together. The neural arch and the body is joined together by these neurocentral joints. I'll show you a picture. You see this picture, these costovertebral joints. This is the neural arch has a center of ossification, and the centrum or the body has a center of ossification. And by the age of this third to sixth year, these two are all the three arch and the body is united by the neurocentral joints. These joints are there. So the process, bony halves of the vertebral arch fuse together during the third to the fifth year. The arches articulate with the centrum at the cartilaginous neurocentral joints. These joints then disappear when the vertebral arches fuse with the centrum during the third to the sixth year. So initially, you are going to have these neurocentral, these are called the neurocentral joints, which are then ultimately called your costovertebral synchondrosis. Is joined because then this is going to be all fused together. So first the neural arches are going to have two and one in the centrum, and then these are going to unite together by these neurocentral joints. Initially they are called the neurocentral joints because in the center you're going to have the neural tube forming in the spinal cord, and then when these joints disappear when the vertebral arches fuse with the centrum during the third to sixth, that is these joints that you see, they are also going to, these neurocentral joints, they are going to finish off, and then it becomes all a neural arch and the body. Okay. Then there is the secondary. So neural arch and the body has the primary ossification centers, which are united, two in the arch and one in the body. They are united by the neurocentral. You see this in this neurocentral joints. These then, when at the age of the third to sixth year, the arch unites with the body, these joints, they finish off. Then is the secondary ossification centers. Then that is again after birth and the time of after puberty, that is when the bone is developing. There are 5 secondary ossification centers which appear. One is tip of the transverse process, one is tip, each transverse process, that means 2, one at the spinous process, superior rim of the vertebral border and the inferior rim. If you see this picture, so 5 centers, tip of the spinous, 2 transverse processes, superior and inferior epiphyseal body. So fuse round 25 years. And if you see this picture, one at the spinous process, two this, then two at the transverse processes, one at the superior of the body and the annular, and the other the below. So these are your secondary centers. These are going to appear, and around 25th year, the whole bone is going to become bony. So we had the 3 steps in the formation. If we recollect, first was your formation of the sclerotome. The sclerotome formed segments. These segments then with around the neural tube, this notochord. Then there was reshuffling of the sclerotome as resegmentation. This resegmentation made the body of the, you see in this, made the body of the vertebra, and the notochord which was running in between, that is going to disappear. Just the central portion, that is going to stay as the nucleus pulposus, and the area of the mesenchyme around is going to become the annulus fibrosus. This is a mesenchymal model, that is, it is a membranous development. This is what we get. Okay. Then we go on to the cartilaginous formation. There are going to be 2 more centers. 2 centers in each centrum and in the neural arch. They are going to appear, they are going to spread out, and they are going to form this cartilaginous model. They are going to make it chondrification occurs. Then we go on to the bone stage. In this, a primary ossification center occurs and the secondary ossification center occurs. The primary are 2, one in the centrum and one in the neural arch. If you see this, on the each side and one in the center. These are ultimately spreading. They are uniting the arch with the body with the neurocentral joints. If you see this picture with the neurocentral joints, and roughly at the age of 3 to 6 years, these joints disappear. All this vertebra, the arch and the body has united. Then we have the secondary ossification centers, tip of the spinous process, transverse process, medial rim of the vertebral body, and inferior rim of the vertebral body. 5 centers you see in this picture, tip of the transverse process, then superior and inferior part of the body, that is articular process, 2 on the transverse process, 1 in the spinous process. This becomes 5 processes. These are the secondary processes that appear, ossification centers. So if you see this chain of events, first is this centrum, that is the mesenchymal. Then the chondrification centers appear in the arch and in this chondrification in the body. This primary ossification centers then start to appear, that is in the body and two in the neural arch. Then that unites it with the neurocentral process, and then you have in the second line is the formation of the secondary ossification centers, and these secondary ossification centers, they are going to ossify the bone completely. Okay, so that is how, again, if you see this picture, the different steps, the mesenchymal formed from the sclerotome, desegmentation, that process has to be very clear. That makes the first, the nerve was in the level of the body, and at the intervertebral disc level, where the two segments met, we had the blood vessel. But when there is resegmentation, the splitting of half of the segment above and below, that leads to the intervertebral disc below at the level of the, where you have the nerve coming out, and the body at the level of the body, middle of the body, you have the blood vessels that is going. So that shifts over the arrangement. And then this is the formation of the centrum. That is the mesenchymal centrum, the first picture. Then you have the chondrification centers which start to appear. They chondrify it, and then you have the ossification centers. You have a primary ossification, and then you have the secondary, which are then ultimately it is going to form the final vertebral column. So you have 3 steps. Then what is the fate of the notochord that was passing through it? Cranial part merged with the basilar part of the occipital bone, that is above, and posterior part and notochord located in the vertebra undergo is degenerated and disappears. The buns located in between the mucoid degeneration forms the nucleus pulposus. So that is how the vertebra or the vertebral column forms. As the vertebrae are formed, they are not straight, they are arranged in 2 curvatures develop. One curvature is at birth, that is the thoracic and the sacral curvatures, where you have the viscera in it. That is the thoracic and the sacral curvatures. And then after birth, the 2 others develop, that is your cervical and lumbar. When the neck holding is there, that is the baby is about to holds the head erect, that is the cervical curvature develops because of that. And when the body weight is thrown on the limbs, that is the baby starts to walk, you develop your lumbar curvature. So this is how your 4 curvatures are going to develop. At birth you just have the thoracic and the sacral, because that is containing your, giving it a cavity containing your organs which are there. And then the cervical curvature, you need it when the head holding is there, and then when the baby starts to walk, the lumbar curvature is going to develop. Then we go on to the anomalies or the malformation of the vertebral column. Commonly, vertebral column problems are scoliosis, kyphosis, and lordosis. You must have heard these terms. What is scoliosis? What is kyphosis and lordosis? Scoliosis is the sideways curve of your spine, often taking the shape of the letter S or C. I will show you. Kyphosis is rounding of the backwards, is what you call as your hunchback. That is slouching posture. That is the curvature. Kub jisko aap kehte hain, that is kyphosis. And lordosis is the normal inward lordotic curvature of the lumbar and the cervical regions of the human spine. That is the normal process. When there is excess of these curvatures, you say it is a problem. So the normal outward convex curvature in the thoracic and sacral region is termed as kyphosis or kyphotic position. That is, they are not to the extreme, they are slightly curved outwards, that is in front and behind. That is the normal outward convex curvature, that is called a term kyphotic appearance. Scoliosis is when it is sideways. If you see this picture, kyphosis is excessive curvature of the spine in the sagittal plane. If you see this in the longitudinally, in the sagittal plane that is anteroposterior to the body. Scoliosis, curvature of the spine in the lateral one, that is the coronal plane. That means in a transverse pliosis. So that becomes, kyphosis becomes a, this if you see the hunchback, that is posteriorly in the anteroposterior plane. So जिसको आप कुब कहते हैं, that is kyphosis, and scoliosis is side to side or coronal. That was the, if you remember these planes. This is congenital kyphosis. These are the spines, that is anteroposteriorly. You can see that the normal spine, and then when there is an excess in this curvature, you call it the kyphotic spine. That is, there is an excess. This is scoliosis. Scoliosis is said to be the anteroposterior change in the diameter, the thoracic and the lumbar levels. That is congenital scoliosis. Different reasons because of it. Then you have this scoliosis, if you see this in another picture. Then there are minor developmental anomalies can be there. The normal number of vertebra may be absent, or a hemivertebra, that is, the vertebra is not completely developed. Half of it is developed, that is called your hemivertebra. See this? If you see in this picture where we have marked the number 3 vertebra, that is half. Full of it is not ossified, so it is called a hemivertebra. This, if you see in this picture, causes failure of one of the quantification centers to appear and subsequent failure of half of the vertebra to form. So defective vertebra produce scoliosis. When it becomes weak in that portion, if the body cannot be, the vertebral column cannot be supported, then it becomes a lateral curvature. So you have the scoliosis, most likely to cause neurological problems. So that is when there is not complete ossification of the vertebra. Then is spina bifida. I think we talked about it when we talked about in the neural tube. What is spina bifida? Spina bifida is that the neural arch that does not close. This spina bifida, when it does not close, we are exposing the spinal cord or the neural tube to the exterior. There can be different reasons or different types of spina bifida. First is spina bifida occulta. Occulta is the skin is there on the top. No prominent neurological symptom is there. No producing out of the meninges or the spinal cord. But you just have a cleft of hair at that level, showing that maybe spina bifida is there at this level. That is called spina bifida occulta. Occulta is something which is hidden. So if it's not giving you any neurological problems, it doesn't make any difference. Then is meningocele. If you see, again a spina bifida is there, skin is intact, but your meninges, they are protruding outward. Again, you might not be having any neurological problem. So that is called meningocele. From the meninges, cele is fluid cavity, fluid filled cavity, which is CSF. Then it can be a meningomyelocele, that is protrusion of the part of the, this blue thing is your spinal cord. So that is also protruding out at the space. That is called meningomyelocele. So you can have spina bifida of different types. That is basically, it is a defect of the vertebral column, not of the neural tube, but it produces effects. Spina bifida occulta, meningocele, meningomyelocele. Then you can have again something which is lachesis. That is, there is no neural fissure or neural tube, the neural notochord or the neural tube, and there is no formation of the spinal cord. So it's just there is bifid or the neural tube is open, it's not formed, it's not closed, and then there is a small amount of the neural tissue which is there, which is called the lachesis. So this condition is called the rashes. You see, this is a picture of the spina bifida. Incomplete fusion of halves of the vertebral arches, resulting in a midline defect, and it is commonly seen in the lumbosacral region. Generally, small bones that make up the spine don't form fully and gaps are seen. This is spina bifida. That finishes the development of the vertebral column. Let's recollect. The development of the vertebra. First, we said the parts. What are the different parts of the vertebra which we have to develop? Then you see this picture, and then the stages which are there. Formation of first the mesenchymal ground is there. Then it is changed into a cartilage. Then it changes to bone, because it is formed around the notochord. Then what is the fate of the notochord? How the costal processes? What are the different types of costal processes? Because we have permanent transversarium, so it's going to have a different fate. And then the anomalies. The stages in the development is because they develop from the paraxial mesoderm. Paraxial mesoderm becomes the sclerotum, that is spreading around the notochord. So that is what it gives rise to the brain. This is how it is spreading around. This is the location. You have the somite, which forms the sclerotum. Sclerotum is going to spread around the neural tube and the notochord. This is migration of the sclerotomes. It spreads around the notochord, this brown structure in between around the neural tube, because the neural tube is along with it, and in the body wall. It is arranged in two ways, loosely cranially, and if you see, and this light pink and the dark one, that is densely caudally. These two arrangements are there. Then we have to form the mesenchymal vertebral column. First step in that is there is this formation of the cephalic and the caudal parts. That is what we call as the mesenchymal stage, or the precartilaginous or the blastemal stage. See in this picture, this is the first model that is being formed in the center. That is, and then there is going to be a process what we call as the resegmentation. This resegmentation is going to shift the cranial and the caudal parts of the less dense and the dense portions, and then they're going to unite together and they're going to form the body of the vertebra. In that part which is less dense, above where the shifting is there, that is going to form a fissure, and this fissure is going to form the intervertebral disc. Outside, that is going to be your part which is coming from the mesenchyme, that is your annulus fibrosus, and in the center is the nucleus pulposus, which is the remnant of your notochord. This is resegmentation. You see again a picture to help you out. And this shows you that this whole of the notochord is going to finish off in the center, and just a small block is left, and that is going to form the nucleus pulposus. And then the pink and the green, they unite together and they form the body of the vertebra. Then intervertebral discs are formed, as I told you. Then we have the vertebra. Then you see the arrangement, the nerve and the artery. That play there, that placement shifts the nerve which was in the center of the body, that goes on because of the resegmentation, changes into the intervertebral disc, and the artery goes to the middle of the centrum, and the nucleus pulposus is the remnant of the cord that is there, and the rest of the notochord is finished off. Okay. Then the body of the vertebra is formed, degenerates. This picture also shows you in the center, you can see this intervertebral disc in the center. This is shifting up because the cranial and the caudal parts are going to shift above and below, and they are going to unite together. So the level of your intervertebral disc is going to change, and then the nucleus pulposus just stays in the center, that is 5 and 6. Then the development of the neural arch from the body, the sclerotum process is going to go backward, both sides of the centrum, and surround the neural tube. And this unites and this forms the neural arch. Side the processes are going to give off, which is going to form your transverse and the spinous processes. This is in the cervical one, it's going to form the anterior and the posterior boundaries of your foramen transversarium. Desegmentation changes the myotomes to bridge the intervertebral disc, that is, they shift from the center of the body to the intervertebral disc. The intersegmental arteries come to the level of the middle of the body, and the spinal nerves to the level of the intervertebral disc. You see this picture, this very clearly explain the diagram, how, what all is going to shift and how the body of the vertebra is formed. This is all resegmentation. The basic process which occurs is resegmentation. Then what we form by the mesenchyme is the centrum, neural arch, and the costal process initially is formed. This is the mesenchymal vertebra. Then is the cartilaginous vertebra. This cartilaginous vertebra has two chondrification centers. one in the body and one in the neural arch. This spreads and this extends into the quadrification of the spinous process and the transverse process as well. Then we go on to the ossification. There are two ossification centers, primary and the secondary ossification. Then these are the primary ossification centers in the body and the arch, which are there, and roughly by the third to sixth year they are fused together. Then is that both have fused. Then you have the secondary ossification centers. You have five: spinous process, two at the transverse processes, above the body and below the body. And so you have five processes which are ultimately going to form the secondary centers and then they unite with the primary center. So this is a summary of the whole of the events of the formation of the different stages of the formation of the vertebra. The notochord formed as just the annulus. Then the curvature that is formed of a normal vertebra is two curvatures: first at birth, that is thoracic and sacral, and the cervical when the head holding is there, and number when the baby starts to walk. Then are the anomalies. Scoliosis is the taking place of the coronal suture at the place that is curvature is there. Kyphosis is the sagittal suture, that is the hunching back or slouching posture, that is called the kyphosis, and lordosis is the normal inward curvature of the lumbar and cervical region of the human spine. And then you have excess of these. This is going to be called as your excess problem. ठीक है. So if you see this picture, this is lordosis, that is kyphosis going backwards, and scoliosis is sideways. That is at transverse is your kyphosis, anteroposterior is your kyphosis, transverse is your scoliosis, and lordosis is at the cervical curvature and your lumbar at the level, that is called your lordosis. You see this? That is increased curvatures. Hemivertebra is something which that the whole of the vertebra does not ossify or quantification does not occur. That is, it develops into a hemivertebra. Half of it is developed, and that can even result into an excess abnormal curvature. That is, again, we can label it as your scoliosis. See this? Then is spina bifida. The neural arch doesn't close. The skin is there, maybe obvious outside, maybe just meninges which protrude, no spine, no neural problem, or maybe just the spinal cord is also protruding and you have nervous problems with it. So you have spina bifida occulta, spina bifida meningocele, and meningomyelocele. All these are different. And rashes again, neural arch is incompletely divided, and this has very little nervous tissue, or then there is problem in the neural tube that forms the problem that is called the rashosis. So that was about the development of the vertebra and the vertebral column. I show you the different pictures again. So, so this picture shows you what are the different steps in the formation of the vertebra. This is a very good picture which shows you how the resegmentation is going to occur. What are the dense parts and the less dense part, cranial and caudal portions, and how do they move, in which direction do they move, and how the body is formed. Okay, thank you. That was about